Jason Taylor, Chair and Lead Researcher here at the Selkirk Technology Access Centre. The Selkirk Technology Access Centre, or STAC, is part of a larger network of 60 TACs across Canada. The TAC model is a partnership with colleges and NSERC to provide support services across Canada for industry and small businesses to really tool up, to manufacturing, to prototyping, to really bring out the opportunities and advancements in Canadian technology. At the STAC, we have 4 lead researchers, 4 research assistants, and currently I think about 12 students that work here pretty much every day. The opportunities that we provide here are focused on advanced manufacturing. So that's 3D printing, 3D scanning and reverse engineering, prototyping in electronics and design, as well as a fee for service. We operate very much like a business. We provide services that companies aren't able to provide locally, such as advanced water jet cutting or advanced 3D printing, 3D scanning, those types of services throughout our network here. The STAC is part of a much larger research center here at the college, and the Department of Applied Research includes geomatics or mapping technologies, advanced computing, and as well as other social sciences. We have typically around a $3 to $4 million budget we work with per year to work with industry partners. So throughout today, we're going to give you a tour of the facility, each area, from 3D scanning and metrology services, reverse engineering, to CNC machining, to 3D printing and laser cutting, and many other things that you're going to explore throughout our tour today.
My name is Sean Curran, and I'm part of the research team here at the Selkirk Technology Access Centre. I'm going to be touring you through the facility today. As Jason Taylor mentioned, we've got a wide variety of machines and services that we offer here at the STAC, and I'm happy to show it to you today. All right, at the STAC we have a variety of different scanning processes and scanning machines in our metrology services. The CMM scanning arm is a coordinate measuring system that utilizes a CMM arm that can get exact touch probe locations that can be cross-referenced with 3D scan data in order to get very, very accurate, very precise measurements that can help local industry. At $120,000, it's not really accessible to most local businesses or businesses in general. So we're able to offer our scanning services and our expertise on this machinery to provide accessibility for companies, both small and large locally, to access these services. We also have a scanner that we've had for many years, and it's called the Creaform Handy Scan. And this utilizes some point data as well as mesh data that can scan a variety of different sizes of equipment or of pieces in order to reverse engineer. So something that's discontinued can no longer make that part. We can actually scan that part and utilize that data to then 3D print, to machine something, to do a variety of processes after to replicate a part. Another scanner that we have is called the ZEB Horizon, and it is a LiDAR data. So we've done some massive point clouds for local companies, really neat projects for finding the topology of different terrain where they can utilize that for design. Local companies concrete 3D printing based on those designs. Another local lumber company utilized it to beautifully sculpt a massive log that we were able to scan with that data. And at $70,000 plus the cost of the software to process that afterwards, Same thing, the STAC allows more accessibility for very specialized equipment to a variety of people, plus the expertise. With the researchers here and the research team, we're able to process that data with expensive software in order to have something usable from it. It's one thing to do the scan and end up with the data, but to have utilization of that data in order to get your end result is something that we specialize in as well. Now we're here in our 3D printer lab at the STAC. So we have a wide variety of different 3D printers, from the $500 consumer model up to the $50,000 to $70,000 commercial. Through 3D printing, we're able to produce prototypes and small one-off parts that sometimes would take a lot to produce on a machine, like milling it out of something or in a variety of other processes. 3D printing is generally lower quantity, so smaller parts, because it is a fairly slow process compared to other manufacturing processes, such as injection molding. So with 3D printing or any of these processes, it's one thing to have the equipment, but it's a whole other thing to how to use that equipment and even teach people how to use that equipment. For the 3D printers, these ones on the side here called the Enders, these are actual 3D printers that, through our new course at Selkirk College called the Digital Fabrication and Design, DFAB. Through that course, we actually taught the students how to set up a 3D printer, build a 3D printer, calibrate it, and print with it. On the other side of things, we do have more production style of 3D printers where a variety of different materials can be used. Some materials that are as strong as some types of aluminum. To be able to 3D print with the multi-materials, you start off with a less expensive material for your prototyping to prove out the design. Some of the materials are compostable in order to aid with byproduct utilization. And we are looking into that in the future as well in order to reuse the 3D printed material and how to utilize the byproducts from it. That's what this conference is all about, the circular economy. So that's one thing that we want to look at supporting as well. Another cool machine that we offer here at the STAC is metal 3D printing. This is something that a lot of people might not even know exists in the world. So we have the Rapedia 3D printer that we purchased at the STAC here. And this machine is a water-based metal paste. So what it is it comes out as a part just the same as the other 3D printers, but instead of being a plastic filament, it is a metal paste. So this is pre-sintering and post-sintering. So sintering is the process where it's heated up to about 4,000 degrees Celsius in order to molecularly bond the metal together. So in this stage, it's very brittle. It's kind of like clay. And in this stage, it is 98% as strong as the steel that it was printed from. So currently we're printing in a couple different grades of stainless steel, kind of a working grade, and also 316L, which is a medical grade. But they're looking to offer a variety of different metals available on this machine as well. So the benefit to metal 3D printing is, first of all, you can make parts that would be very hard, if not impossible, to machine on a metal working machine. And then the other benefit to it is less wastage of materials. So generally, to make something like this, you'd have to take it from a block of steel and whittle away it all, and then you're wasting all that materials. Where this, we're printing just what we need. So you're actually saving materials, you're saving time, you're saving money in the long run. It's very specialized, kind of what parts we would utilize. And after the part is done, you could actually finish machine it on a different type of CNC machine. So yeah, we're pretty excited to offer the metal 3D printing here at STAC because it is definitely future technology. So now we're going to talk about the CNC machining capabilities at the STAC here. So we have a variety of different CNC machines. CNC stands for computer numerically controlled. Basically what it is instead of manually controlling it, you're utilizing a computer via programming or to control it to run a machine. So the CNCs that we have available here, you see a couple in the background behind me, do metal and some harder plastics. We have ability to do different types of woods. We have abilities to do different types of plastics, different types of foam in both 3-axis, so that is X and Y and Z, plus also in 4 or 5 axes, so a machining head that can rotate in a multitude of axes. Something that we always stand by is to collaborate with local industry and not compete with local industry. Especially with these metal machines, you know, we're not a machine shop. That's not our goal here. Production manufacturing is not something that we generally do. What we do is something that's being provided to us through a drawing, or we design it, or we 3D scan it, and then test it out, and then we can machine it. So the metal milling and lathe machines that we utilize here are just for small quantities. Testing it out, making sure it works properly, making some parts for another project, whereas if a company is wanting a higher quantity, then they could take that on to another local machine shop or such. Same things with signage. So, you know, we can make some signs on the CNCs, but we prefer to collaborate with the local sign shops. And we actually have a local sign shop that has worked with us for several years to come in and utilize the machine as a commercial user. So instead of him having to invest in a $40,000 machine, he can come with a day rate usage or have us create something through a subcontract for him, and then he still deals with his end customer, and everybody wins and benefits. Here at the STAC, we do a lot of research, applied research, where we're making stuff for people. But we also do a lot of instruction. So I mentioned the digital fabrication and design course. So that's the new 2-year course at Selkirk College. And that course teaches the students on a variety of different machines, one of them being CNC routing. So the machine behind me is the one that we teach the students on. And these machines can be used to make a wide variety of stuff. So you can make some furniture, you can make shelves, even up to 3D terrain maps. We've made some pretty neat terrain maps, one for a local stream keeping preservation society to kind of show the watershed of a local stream in order to help them kind of share their story. A lot of people might not realize the scale of our facility. We've talked a lot about our capabilities and the different machines, but we're back here in our back section of our warehouse where we're able to house some larger equipment like a water jet cutter. So the researchers behind me are setting up the water jet cutter right now, and some people might not know what a water jet cutter is. So water jet utilizes a very high pressure stream of water that picks up garnet abrasive that can cut through a variety of different metals. Metals, even rocks, plastics, a variety of different composites in order to provide stuff that could not be cut in other ways. Metal that's cut without heat affected zones. There's lots of benefits to the water jet and what it's able to cut. So we're able to provide local water jet cutting. So some other companies that would have to go to larger centers like Vancouver or Kelowna even, mostly Vancouver, to get their water jet cutting, we're able to do it here. So that's saving people's cost on shipping, that's allowing to keep it local, and that's allowing us to teach our student researchers on how to run these machines while we're running projects as well. For internal projects or things that we need to make, there's a huge benefit to it. If we need a new bracket or a portion of a prototype, we can have that cut within minutes, literally here. Some of the cool things that we've done on this machine is the local sign shop. They were making these beautiful acrylic pieces that was actually a memorial for some paramedics, and we were able to water jet cut all the parts for him. We're able to make some custom brackets and different parts for some local industry partners. We've been able to cut a variety of steels for a local mill processing facility for one of their new product lines for some wood flipping processes. Yeah, and we're excited to be working with another local fabricator, and they come to us for our water jet cutting so that they can supply parts to our larger local industry like tech resources and such. So we're partnering with smaller local companies in order to provide services for larger local industry. So it's a really benefit for everybody.
So I hope you enjoyed that virtual tour today. We definitely look forward to being able to work with you into the future. If you have any questions or comments about the opportunities and services we offer here at the STAC, please email us at stac@selkirk.ca. Thank you.